In order to start with our triangle inequalities, we have to practice with some basic inequalities that we learned back in algebra. So if we focus on number 1, we want to solve this just like a regular equation. So we start by subtracting 4 from both sides. We have 2x is greater than. Now we want to do the subtraction over here on this side. Negative 18 minus 4, which is going to give us negative 22. We finish this off by dividing both sides by 2. And we end up with x is greater than negative 11. Now, a common error that students might make here is they might want to flip that inequality symbol. We only do that if the coefficient, so if this number right here, if that is negative. Because if we're dividing by a negative number, that's when we flip our inequality symbol. But here, because that 2 is positive, it's going to stay the way that it is. The only difference with numbers 2 and 3 is that there are different types of inequalities. So we still follow the same process as we would if it was equations, only now we just have the inequality symbol. So go ahead and try numbers 2 and 3. What I want you to do is pause the video, and then once you're done with the questions, numbers 2 and 3, then replay the video and we can start with the triangle inequality theorem. Okay, so if you work through problems 2 and 3, hopefully for number 2, hopefully for number 2, you ended up with 8 is greater than or equal to x, and for number 3, you got negative 2 is less than x. So let's take a look at our triangle inequality theorem. And it's one of those theorems, again, where we actually read through it and it might not make a lot of sense, but in practice, it really starts to. So, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater. And I apologize for the precision of my stylus. So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So as an example, if we had a triangle with sides 3, 4, and 5, hopefully we're at least a little bit familiar with our 3, 4, 5 right triangle. What this theorem tells us is that any two sides, when we add them together, their sum will be greater than the remaining side. So if we wanted to check if our 3, 4, 5 triangle could in fact create a triangle, what we would do is we would add our groups of sides together to see if they are greater than the remaining side. So A and B, 3 and 4. 3 and 4 is 7. 7 is in fact greater than 5. We're good. Next, we have 4 and 5. 9 is greater than 3. We're good. Then we have 3 and 5. 8 is greater than 4. So this triangle works. It is possible to have a triangle with the sides 3, 4, and 5. Now, you might be sitting here saying, well, obviously I know that 4 plus 5 is going to be greater than 3. In this case, it might help just to check the two smaller sides. Next, we have our whole part theorem, which I don't really think we need to spend a lot of time on because it's pretty much common sense. But again, in math, we need things formally in writing. We need official theorems so that if we ever have to prove something, we have a reason for it. So it says that if we have, let's see, if we have two parts that add up to the whole, then the whole is going to be greater than the individual parts. Makes sense, right? So if this is 3, if this is 5, the whole is 8. 8 is going to be greater than 3. 8 is going to be greater than 5. The same thing applies to angles over here. So next, we have the exterior angle inequality theorem. The measure of an exterior angle of a triangle is greater than the measure of either non-adjacent, again, I apologize for the stylus, I have to calibrate it a little bit better, non-adjacent interior angle. Again, we know because of the exterior angle theorem that angle 3 is equal to angle 1 plus angle 2. That's what the exterior angle theorem taught us. This combines the whole part theorem with the exterior angle theorem. And it's telling us that angle 3 is going to be greater than angle 1, and it's also going to be greater than angle 2. Which again, if you think about it, it's common sense, because if the two add up to angle 3, of course they're going to be smaller than their sum. Now we come to specific inequalities in triangles. And you can go ahead and pause and read through all this. It's once again kind of math taking things a little bit more difficult than they really need to be. But really what we want to do is we want to look at our side lengths. So even though this doesn't look like a 3, 4, 5 triangle, which would be right, we're going to use those just as pretend. What these theorems say is that the angles opposite of the sides all correspond in order. So we know that the smallest side is 3. That means that the smallest angle is going to be angle B. Our middle or medium length side is side 4. So if we're putting our angles in order, angle A is going to be that middle angle. Finally, we know that 5 is our longest side, which means that angle C is our largest angle because it's opposite of that angle. Now for some examples with using our, using our inequalities. If we want to name the largest angle and the smallest angle of the triangle. So if we remember, our triangle inequalities told us that we can match up our sides with our angles, and that can help us determine which are the largest and which are the smallest. So let's see here. We want the largest angle. So what we do is we look for the largest side, or the longest side, I should say. Oops, sorry. So our longest side is side 10. The angle opposite is angle D. So our largest is angle D. Our smallest now is going to be opposite the smallest side. Our smallest side is 6, which means that our smallest angle is E. Simple enough, right? For number 2, now of course we have to incorporate some actual calculation here. So if we know that we have 46 and 108. We want to do a quick calculation to figure out the measure of angle L. So if we add 46 and 108 and then subtract it from 180, we know that angle L is 26 degrees. Again, we want the, well, not again, because the other we wanted angles. Now we're looking at sides. So we want the longest side and the shortest side. The longest side is going to be opposite the largest angle. So since angle N is the largest angle, we know ML, let's put our segment symbol there. ML is the longest side. Our shortest side is going to be opposite of 26, MN. When we're looking at number 3, we want to complete each statement with either less than, greater than, or equal to. So here we're given that triangle ABC is a right triangle with measure C, 90 degrees. So we want to draw our triangle so that we have a right triangle. We know that C is our 90-degree triangle. So just so that we have a visual, go ahead and put in A and B in either of the other vertices. And we want to look back at the first page of our notes to help us get through these problems. So first, we're asking the measure of angle C is what compared to the measure of angle A? Now, we know that in a right triangle, 90 degrees is going to be the largest angle. So the measure of angle C is greater than the measure of angle A. For the second example, the measure of angle C is what compared to the measure of angle A plus the measure of angle B? This is where we want to look back at our triangle inequality theorem. So the first theorem that we went over on the front page, look back at your triangles and look at the inequalities. C, so any side of the triangle is going to be less than the sum of the other two sides. Finally, this is where we really want to use our triangle that we drew. AC is what compared to AB? Well, AB is our side opposite of the 90-degree angle. Because C is our largest angle, we know that AB is going to be our largest or our longest side. So AB is going to be greater than AC. So the way that we would write this is AC is less than AB. Number 4 is where we're going to have to do a little bit of work. So the lengths of two sides of a triangle are 8 and 13. Then the length of the third side must be greater than what and less than what? Okay, so we have our triangle inequality theorem. So what we want to do is take our two sides, 8 and 13, and we want to set up some inequalities. We know that 8 and whatever the other side is has to be greater than 13. We also know that 8 and 13 have to be greater than whatever the third side is. Finally, we know that our third side plus 13 has to be greater than 8. What we do is we solve these inequalities, which I will let you do. We get x is greater than 5. 21 is greater than x. So the way that we read this is x is less than 21. And over here we have x is greater than -5. Now remember, we are talking about side lengths. That means that this guy over here doesn't mean anything to us. See you later. Okay. Now we take what we have here and here, and we fit it in here and here. So x is greater than 5. So it has to be greater than 5 and less than 21. So that's how we go about doing this type of problem. Okay, so this is where I want you to start to try to do some of the problems on your own. I want you to do number 5 and number 6. Okay, so if you're doing this at home, if you've missed class and you're trying to catch up, I want you to come in with these worked out, and I can check them when I see you. Okay, and I will see you guys later.